All right, guys. Here we go. We're going to give you a quick little video. I'm posting one from Red Pen, Black Pen. He does theoretical stuff, but you got a couple of examples on the top of your guys' worksheet. But again, we're going to work with this for a little bit. So it's related, or the proof is related to implicit differentiation, and I'll tackle that on Monday when I'm back. So the idea is that you're going to use its derivative of inverse trig functions, and they look like this. So they look like that sine of -1 over x, and then we have another way to write it, which is arc sine. So these two things mean the same thing. All they're talking about is the inverse trig function. So these have some very specific formulas. Use your reference sheet. You'll see them. If you want to see the theoretical version ahead of time, watch the Red Pen, Black Pen. But it's super fast. Like, I think it's more of a see how fast he can do it kind of thing. So, but it is pretty informative, so you can check that out. Khan Academy has a couple of things too, but not a lot of examples. So I'm going to give you guys an example. So if we're sitting with this here, we also need to know what the formula is. So the formula is, so the actual derivative of arc sine, or inverse cosine, is -1 over the square root of 1 minus x squared. And on your worksheet on the top, we do this. We give you the box is one way to use it. Some other ways you'll see it is u, and then always you have to do times u prime or the box prime. So we're always multiplying by that derivative of the inside. So if we take something like this, and let's just change this idea to this is u. So if this is u, and I take my derivative of the whole thing, when we take the derivative of y, I just get dy dx. That's that whole idea of implicit differentiation that we talked about yesterday. And then from there, I use my formula, which I have -1 over the square root of 1 minus. Now, here's where you just got to pay attention to what's going on. This was my u, which is x squared because of my formula. Whatever u is, I have to square it, times the derivative of the inside. So don't forget that little idea of the chain rule piece, or it's always the derivative of the inside, times 2x. So when I clean all this up, my dy dx is equal to -2x over the square root of 1 minus x to the 4th. Because I just square that there. Okay? So that's how you're going to use the inverse trig functions today. So the biggest, I keep saying the biggest thing you guys have to know is look at your reference sheet for these. There's all 6 of them: secant, tangent, all those different things. They all look like this. Some of them are 1 plus x squared. Some of them are x squared minus 1. They're all a version of this. Two things you got to realize. When you plug this in, when you plug your u in, don't forget to apply the power that's there. And don't forget to multiply it by the derivative. Okay? So just one little quick example today for you guys so you guys can get going. And we will talk to you later. I'll see you guys on Monday.